And welcome back. So hopefully you were able to locate your trig chart. So this problem, it says find sine of 40. So all of our angles have very specific ratios and very specific patterns, and that's going to help us solve here in a little bit. So the easiest way to find sine of 40 is I'm not going to use the calculator. I'm going to go to the trig chart, and I'm going to look for sine, and my angle was 40 degrees. So my trig chart tells me that sine of 40 degrees is 0.6428. So what's sine of 40 degrees? Well, the trig chart told me that it was 0.6428. And that's how our trig chart works, is instead of having to go to the calculator and type it in and all of that, I can just use my trig chart. So to find tangent of 53 degrees, I'm going to go back to the trig chart. Now I'm going to be careful because I'm looking in the tangent column. So I'm going to look for tangent 53 degrees, and that's 1.3270. And I'm not going to round it. I need to be really careful. So I'm going to leave it as 1.3270. The key thing to be aware of on these is that they're already rounded. Like sine of 40 is a lot longer than 0.6428. So that's why our chart goes out to 4 decimal places. And so I'm going to keep it 4 decimal places out to give me the most accurate answer. So I'm going to give you a minute. See if you can use your chart to find cosine of 70 on your own. You're just looking at your chart. And cosine of 70 is 0.3420. That's cosine of 70. So now I'm going to use trig to find a missing side. If we take a look at this problem right here, if I wanted to do Pythagorean theorem, I couldn't because I only know one side. I don't have two sides to do Pythagorean theorem. Now 34 degrees is pretty close to 30, 60, 90, but it's not 30, 60, 90, it's 34. And that's when trig comes into place. So trig is what you use when all else fails. So trig is what we use when all else fails. Some people like to use trig all the time, and that's okay too. But if you can use Pythagorean theorem, use Pythagorean theorem. If you can use one of your special right triangle charts, use that. But when all else fails in this particular problem, I can't do either of those options, so I'm going to go with trig. So just like before when we found our angle and then we labeled our sides, I'm going to do the same thing here. They didn't give me information on that angle. It doesn't matter. I know that I have a right triangle and they marked angle A as 34 degrees. So I'm going to use 34 degrees. I'm going to use angle A as my marked angle. And now I need to figure out which side is which. So I circle the angle that they gave me. If I go across from it, so that would be my opposite side. If I go across from the box, there's my hypotenuse. And then my last side would be the adjacent side. Now, I have 3 trig formulas. I have sine, cosine, and tangent, and I don't need to use all 3 on this problem. There's nothing on the adjacent side. There's not a variable, there's not a number, which means I can cross it out because I'm only going to use the opposite side and the hypotenuse. So if we go back and we look at our trig formulas, which one used opposite and hypotenuse? And that's sine, or so. So that's the formula that I'm going to use on this particular problem. So I'm going to use sine of theta equals opposite over hypotenuse. And I'm using this formula because there's nothing on the adjacent side. So I don't care about the adjacent, so I'm going to use opposite and hypotenuse, and that's my sine formula. And now I'm going to fill it in. So sine of, well, the angle, they actually gave me a number now. Sine of theta, my angle is 34. Equals, opposite is x, I don't know it, and then the hypotenuse is 13. Well, sine of 34 is a number, and that number, it goes back to our trig chart. If we go take a look at our trig chart, and I look for sine of 34, it tells me that sine of 34 is 0.5592. So I'm going to go back to that problem. I'm going to cross out sine of 34, because my trig chart told me that sine of 34 was 0.5592. And now all that I need to do is solve for x. So if you have x divided by 13, the easiest way to get rid of that would be to do the opposite, and that's multiply by 13. So now I'm just going to go to the calculator, and I'm going to go ahead and figure out what is 13 times 0.5592. And that is So x is 7.2696. Now, they didn't tell us what to round to, so I could say 7.2696, but most of the time we're going to round to the hundredth. And when I say round to the hundredth, I'm talking about our final answer. I never ever round these. I never ever round my trig chart numbers, but my final answer, whatever x is, I can round that to the nearest hundredth, which is 2 decimal places out. So if I look at the 6 and I go past it, 9 would tell me that this 6 should go up to 7. So I'm going to say that my answer is x is approximately, that's what those 2 squiggles mean, approximately about, it just means that I rounded. So x is about 7.27. And a quick way to check this is just check. Our hypotenuse is 13, 7.27 smaller than 13, so we're in the clear. And that's how we use trig to solve for a missing side. So taking a look at the next one, start by figuring out what's the marked acute angle that they gave you. And that's angle B, that's 67 degrees. So now I'm going to go ahead and label my sides. So across from 67, that would be opposite. Across from the box, that's my hypotenuse, which makes my last side adjacent. Now, there's nothing on the opposite side. There's no letter, there's like no variable, no numbers. So I'm going to go ahead and cross out that because I don't need that. And then I'm going to figure out which formula uses adjacent and hypotenuse. So if I go back, which formula uses adjacent and hypotenuse? Well, that's cosine. So I'm going to use cosine of theta equals adjacent over hypotenuse. So cosine, I'm going to fill it in. So cosine of 67 equals x over 18. Okay, now cosine of 67 is a number. So I'm going to go to my trig chart, and I'm going to figure out what is cosine of 67, and that's 0.3907. So I'm going to go back, and I'm going to cross out cosine of 67, and I'm just going to put what it was, 0.3907. Because this is a lot easier to solve than what I had before. So if we have x divided by 18, well, to get rid of that, I would multiply both sides by 18. And then I'm just going to go to the calculator and type that in. So 18 times 0.3907. And be careful when you're typing things into the calculator. Make sure you don't mistype anything. And I get a long decimal. I get 7.0326. Now, 2 decimal places out, if I look past it, I don't need to round the 3 up. So I'm going to say that x is approximately 7.03. And that's how this works. So a little trick to remember is that when x is up high, we end up multiplying, right? We multiplied on the last one, we multiplied on this one, and that's how we got our answer. So taking a look at another one, I have this angle marked down here. I always have to figure out first, like, what's my theta? What's my acute angle? So that would be 52. And asking yourself, what's 20 going to be? That would be opposite because it's across. X is going to be our hypotenuse. And I have nothing on the adjacent side. I can go ahead and cross that out. I don't have anything there. Now, if I have opposite and hypotenuse, think, would I use sine, cosine, or tangent? And remember, you don't have to memorize the formulas. You just have to look. So opposite and hypotenuse would be sine of theta equals opposite over hypotenuse. Now I'm just going to fill in. So my angle was 52, so sine of 52 equals 20 over x. Okay, now x is now in the denominator of the fraction. It's not in the numerator, but I'm going to deal with that in a minute. My first thing is I need to figure out what is sine of 52. That's a number. So if you go take a look at your chart, I'm going to give you a minute. Go look at your chart and see if you can find sine of 52. If you found it correctly, that would be 0.7880. And now x is in the denominator, have to be careful. Well, when x was up high, I multiplied. Now that x is changing spots, I'm going to divide. And the way I'm going to divide is I'm going to swap out my decimal for x. So I need to be really careful. To get x, it's going to be 20 over 0.7880. I'm not going to divide the other way. If you divide the other way, you're going to get a really, really small number. It's way too small. It's not going to work out. It's always the side divided by that decimal. So 20 divided by 0.7880. So think of it this way. When x is up high, we multiply. When x is down low, we divide. So when x is up high, we multiply. When x is down low, we divide. And I know what to divide by what. Is like this 20 always goes first, swap out the x for the decimal. So now I'm going to go to the calculator and type in 20 divided by 0.7880. And I get a long decimal. It's 25.3807. So x would be about 25.38. Just like that. So just another example of what one would look like if you were going to divide is, let's say that you had sine of 29 equals 10 over x. Well, sine of 29 is 0.4848, and it wouldn't be this divided by 10. I'm going to swap these parts out. So it would be 10 divided by 0.4848. So that's how I'm doing that problem. So be really careful with those division ones. Okay, now let's take a look at a word problem. All this wants to know is how high above the ground is the UFO? And they give us a picture. So hopefully we're over here. Hopefully we're not in this building where the UFO is coming with our aliens. Maybe they're nice, we don't know. But the question is asking you for how high above the ground is the UFO. So that's vertical, this is my x. Now, I have a right triangle here. So if I want to go through and kind of carefully mark this right triangle, I can do that. I can add in that right angle in there where that building is. And then just ask yourself, like, if I can't use Pythagorean theorem on this problem and we can't do a special right triangle chart, this would be a trig problem. So trig problems typically have an obscure acute angle. So I'm going to start by circling that 12 degrees, that acute angle, and then label the sides that I have. So if I go across, that would make x opposite. I'm going to give you a minute to think about it. What would 1200 be? That would be adjacent. Now, there's nothing on the hypotenuse, which means I want to go look at which formula does not have hypotenuse in it. So if I go back and look, I don't want hypotenuse in it, so those are out. This is going to be tangent. So if I go down to this problem, tangent of theta is my formula. So tangent of theta equals opposite over adjacent. And I want you to see if you can figure this problem out. Go ahead and plug in all that you know. Use your trig chart and then decide, are you multiplying or are you dividing? So when we plug in our values, we get tangent of 12 equals x over 1200. X is up high, so I know I'm going to multiply, but I need to be careful. It's not going to be 12 times 1200. Tangent of 12 is going to be 0.2126. And so that's what I'm multiplying. I'm going to multiply 1200 times 0.2126. I use my trig chart to find that number. And I get that x is about, it's already rounded for me, 255.12. And if I look at this problem, meters. So this UFO really is like only 255.12 meters above ground. I would really hope I'm way over here. I would really hope I'm 1,200 meters away. So hopefully you know some more stuff about trig now. Remember, if it just wants the trig ratio, we didn't do any solving on the front. We were simply just finding our ratio. We didn't even use the trig chart. But if you have x as a missing side, so once we actually start solving, we have missing sides, then I have to use my trig chart. Then I use the whole up, high, multiply, down, low, divide thing.